Alright guys, so we learned graphing by hand for systems, we learned substitution method, and we learned the elimination method. So the next thing we need to learn is how to approach word problems for systems of equations. So we're going to practice that today. If you notice, the packet that was handed to you has a bunch of word problems on it, and as you go, in the beginning, there's questions that prompt to kind of help you work through the problem. And then the further you get with the questions, those prompts start to go away until they go away completely. So at the point where those prompts go away completely, you should have a good idea at how to approach these questions yourself. So again, those prompts in the beginning are to help you start thinking about how to come up with these equations, but eventually you're going to need to figure that out for yourself. So let's take a look at the first question. Michelle is making goodie bags for Christmas filled with chocolates and candy. Chocolates cost $2.50 per pound, and candy costs $3 per pound. So A says write an equation showing that Michelle spent a total of $40 on chocolates and candy. B says write an equation showing that Michelle bought a total of 15 pounds of chocolate and candy. And 3 says solve the system of equations to find out how many pounds of chocolate and how many pounds of candy Michelle bought. So the first thing that I'm going to tell you guys to do when you approach a word problem is the same thing that we did when we were solving equations and looking at word problems. Identify a variable. Well, in this case, we're talking about systems. So we're talking about finding two different things. We're going to have two different variables. You can name them any letters. To be consistent, I'm going to stick with X's and Y's. So you need to tell me what letters you're using and what things they're standing for. I will expect you to be doing this part. So I'm going to use an X and I'm going to use a Y. So if you don't know what those variables stand for, look at the question. Figure out what you're trying to find. What are you trying to answer? Those two things you're trying to find are what your variables represent. So if I come down here, it says I'm going to solve this equations to find out how many pounds of chocolate and how many pounds of candy Michelle bought. Those are my two variables that I'm going to identify here. So I'm going to say that X is going to be number of pounds of chocolate. And again, I'm being specific. I didn't just say X is chocolate because I don't know what that means. I don't know if that's the price of it. I don't know if that's the weight. I don't know if that's how many pieces. It's the number of pounds. Be specific, especially because you're going to have to put labels on these answers later. The more you can do now, the more accurate you're going to be later. So the other one is how many pounds of candy. So I'm going to say the number of pounds of candy. So I have my two variables named and identified. So now I can start looking at setting up equations. So part A says write an equation showing that Michelle spent a total of $40 on chocolates and candy. So if she spent a total of $40, I know that something is going to equal 40, right? Total. Total also means we are usually adding things together. So I'm adding something and it needs to total 40. So if we're talking about money here, then I need to be talking about money on the other side of that equation. So chocolates cost $2.50 per pound. Well, X is my number of pounds. So I'm going to say 2.5 or 2.50 if you're more comfortable with that. They're the same thing. So 2.5 times the number of pounds of chocolate I bought. So 2.5x, and I'm going to add that to the cost of candy, which is $3 per pound. Pound is Y. That represents the number of pounds. So if I take the cost times how many pounds of chocolate I bought and add that to the cost and how many pounds of candy, it should come out to $40. That is my first equation. So I need to come up with a second equation in order to have a system. It says write an equation showing that Michelle bought a total of 15 pounds. So I'm no longer talking about money. I'm talking about a total of 15 pounds. The price per pound has nothing to do with my total number of pounds in this one. So I'm not including the price again in this equation. That was included when we were talking about the total amount of money I spent. So in this case, we just want to know the total. So I'm adding something together, and I should get 15. Well, if it's a total of 15 pounds, I'm adding my pounds of chocolate, which is X, and however many pounds of candy, which is Y. When I add up how many pounds I bought of each, I should get a total of 15 pounds. So we now have our two equations. There's our system. So I can write that down here. It's 2.5x plus 3y equals 40. X plus y equals 15. So part C says solve the system of equations in order to figure out our two variables. Most word problems are going to set themselves up to use elimination method. However, you can use any method to solve this, but we're going to go forward with elimination method. So if I look, I can easily multiply this second equation by something to get opposites of the top. Now, I could multiply by negative 2.5. However, if I don't have to deal with all those decimals, then I'm not going to. So if I look here, my y's, I have a 3 and I have a 1. So if I multiply the bottom equation, everything in it, by a negative 3, then that'll give me the opposites in the y's that I need. So I need to distribute that to everything in that equation. So my top equation stays the same, 2.5x 3y equals 40. I'm going to multiply negative 3 times x is negative 3x. Negative 3 times y is negative 3y equals negative 3 times 15. Don't forget to multiply that one as well, is negative 45. I have opposites, so I'm going to draw my equal sign and my plus, and I'm going to continue. So 2.5x plus negative 3x is going to give me negative 0.5x. 3y plus negative 3y, they cancel each other out, bring down my equals. And then I have 40 plus negative 45 is negative 5. So at this point, some of you are probably saying, Miss Scott, you don't let us use decimals. In word problems, when we're dealing with money, they are perfectly okay. You may work through with them. I'm going to divide both sides by negative 0.5. And be very careful here because some of you are going to want to tell me that that's half of negative 5. It is not. Be very careful. If you put this in the calculator, it'll tell you the same thing I'm about to tell you. You get x equals 10. Dividing by 1/2 is like the same thing as multiplying by 2. So I'm going to put my label on here. If I look back, my x said it was the number of pounds of chocolate. So 10 pounds of chocolate. Do you see how easy, if I would have labeled that specifically, do you see how easy it would have been for me to just say, oh, $10, right? I get that a lot. Make sure that you're being specific so that your labels are correct. So that's half of my answer. I also need to find out how many pounds of candy. So I know x equals 10. So I can come back to one of these equations, replace my x with 10, solve for y, and I get y equals 5. And again, if I'm not sure what it is, pounds of candy. Once I have my labels on, then I am finished. I answered the question. So notice, this is a little different than when I just give you a system and ask you to solve it. For those, you need to write them in a coordinate point. Here, it's not asking for a coordinate point, it's asking for something specific. How many pounds of chocolate? I answered that. How many pounds of candy? I answered that. So we are done with that first problem. So let's take a look at number 2. Number 2 says 20,000 tickets were sold to the Green Day concert. Stage level seats cost $105 and higher level seats cost $75. If the total money collected from selling tickets was $1,740,000, how many tickets of each type were sold? So that's the question it's asking. How many tickets of each type? So I'm going to define my variables. So X and Y, each type. So there's two types. The two types were stage level and higher level. So how many tickets? I'm saying the number of. So number, I'm going to call my X my stage level. Tickets. And I'm going to call Y my number of higher level tickets. So my rule of thumb is I usually just take the first thing that's mentioned in the problem, make that my X, and then second thing and make that my Y. You don't have to do it that way. I just like to be consistent. So part A says write an equation showing that 20,000 tickets were sold. Well, this was a total of 20,000 tickets were sold. So I'm not talking about price in here, just saying the total number of tickets. So my number of stage level tickets plus my number of higher level tickets should equal 20,000 total tickets. In B, now we're talking about ticket sales. We're talking about money. So now my cost is going to come into play. So my stage level tickets were $105 and my high level were $75. So here again, it needs to total 1,740,000, and I need to take the cost times the number of each ticket sold. So 105 for my stage level. Stage level is X, so 105X plus $75 for the higher level, plus 75 times the number that I bought, which is Y. So there's my second equation. I'm going to transfer them back down here. And then we can use the elimination method and solve. So I'll let you go ahead and solve that on your own. Elimination method you guys should pretty well have down. So let's flip over and take a look at number 3. So number 3 says Brody's Gourmet Pretzel Shop specializes in selling the very finest chocolate-covered pretzels. Banky bought 4 white chocolate pretzels and 6 dark chocolate pretzels for $10.50. Holden bought 8 white chocolate and 3 dark chocolate pretzels for $9.75. So A says write a system of equations to represent this situation. So already they have you now trying to come up with the 2 equations yourself. This one is going to be slightly different. The other ones, we talked about money all in the same equation, and then we didn't use money again in the other. In this situation, though, we have one person who bought 4 white, 6 dark for a total of $10.50. That's going to be one equation. So Benke's situation will set up as a single equation. Then we have another situation. Holden bought 8 white chocolate and 3 dark chocolate pretzels for $9.75. That's the total. So Holden will represent the second equation, his situation, what he bought and what it cost. So I'm just giving you the background. That one then you should be able to try to go through. And then I'm going to give you one more pointer so that you guys can get moving on this and see what you can do. Number 4, whenever we have percentages, you need to change those to decimals to work them into the problem. So 6% To change to a decimal, I divide it by 100. That's going to become 0.06. No longer has the percent symbol when you put it in the equation, when you're using the decimal. 9% divide 9. 9 divided by 100 gives you 0.09. So those are what you're going to be using in the equation. You can't use the 6% and 9%. Use 0.06 and 0.09. Okay, we will continue to work on these tomorrow. Do the best that you can today and write down any questions that you might have so that we can cover it and answer them tomorrow. Have a nice day, guys.